Marcel, and I'm presenting Objective-Smalltalk. What is Objective-Smalltalk? Well, it's an embeddable Smalltalk language, and I just learned you have to capitalize the T, and then everybody knows that it's not a completely compatible Smalltalk 80. It runs on Mac OS, iOS, Linux, Windows, and what it is, it's an Objective-C framework, so not a VM or other kinds of things that implements the language. And it is also a complete peer and has full interoperability with Objective-C and therefore with the rest of the ecosystem. That's sort of the basic thing of what it is, and then there's the where did it come from, why is it here? And that's really most of what I want to talk about today. And the thing is, it generalizes objects and messages to components and connectors. And it does this in order to solve architectural mismatch, which I think is one of the major problems we face today in software construction, and therefore enable composition. And by enabling composition, that's kind of the same thing as improving and enabling better expressiveness, because in order to be expressive, we need to be able to compose the things that we already have. The primitives that we have provided just aren't sufficient because we need to grow. So what's this architectural mismatch this guy is talking about? Well, I've sort of identified three basic versions. The first one, which was kind of where the name came from, is pretty much packaging mismatch. Then later somebody identified that interactive programs don't really match, the architecture of interactive programs doesn't really match the implementation technologies that we use to implement them. And that's one of the big reasons why writing interactive programs sucks so horribly. And it hasn't really improved since the 1990s. I have a book on user interface programming languages from the early 90s, and you could publish the same book today. It's all the same problems. And then looking at that a little bit more closely, actually, I think it's a more fundamental issue that the abstractions that we use and to think about programming really don't match the systems that we're writing. Programs are different than systems, and computers don't actually compute most of the time. But we program them as if that was the main thing that they do, that they compute all the time. So first, packaging mismatch, and that was a wonderful paper that I really recommend everybody reads, called Architectural Mismatch: Why It's So Hard to Compose Software Out of Existing Parts, by Garland et al. In '95. And it was great because this was the software architecture group at Carnegie Mellon, and they said, we need to write some tools. And we're the software architecture people, so damn it, we're going to reuse some packages and we're going to stick them together and it's going to be wonderful. And then they reported on the car crash that ensued. And it's an amazing paper. And basically what it boils down to is that very often, you have the functionality that you want is available. It's just not available in a way that you can actually get to it. So for example, there is some function and it's in an application. So how do you get to it? Well, write some Apple script. Oh my God, rather not reuse. And there's a bunch of these. They catalog them. A very popular one is who has the thread of control, because everybody always wants the thread of control. Typical framework problem. Problem here with Smalltalk. Smalltalk wants the thread of control. The operating system frameworks want the thread of control. Well, fight. And therefore, the basic thing you get out of this is that you need to really minimize the assumptions that your software makes about its environment. Basically, it's better to be easy to talk to than it is to be right. So, get off the right being if it makes your thing easier to reuse. And this is actually this is not a completely new realization. Certainly the hexagonal / ports and adapters architecture talks about the same thing, right? Don't plug into the environment first. Do your thing first. Get that as a library, then adapt to the environment. And the naked objects pattern is very much the same kind of thing. general, the UI becomes a sort of a general, a small thing that you plug your thing into. So that was the first. That was packaging mismatch. So interactive programs. There's a wonderful paper. Programs, and just not provocative title at all. Programs equals algorithms plus data structures plus architecture. And again, there's the realization that most interactive programs just don't look like y equals f of x. Right? On my iPhone, none of the programs on that phone takes some arguments, computes a result, and then terminates. None of them do that. But the programming languages all do that. They're all procedural, essentially. And that's pretty much also what the difference between transformational and reactive programming. Reactive programming has sort of surfaced, basically because functional programming is transformational by default, and so they had to jump through some hoops to try to become reactive. With objects, we have an easier time because objects are reactive by default. They sit there and you message them and they talk to you. And as an example of this problem, I held a talk at Modularity in 2016, and I used a temperature converter. And just really simple model. Here, it has a temperature and two methods to convert between them. And then you start adding UI, and you have to tear everything down because you need to add communication. And then you add persistence, and you have to tear everything down again, and the communication patterns become incredibly complex. And then you add another temperature, and you have to tear everything down again because everything has to interact with everything else. And then I just showed the same thing with data flow constraints, and it was just add this constraint. Have a new requirement, add another constraint, add another constraint, add another constraint. No tearing down, just linear, straight down. And so the interesting thing, I think, is that this actually generalizes. It's not just interactive programs, it's programming in general. And there's a wonderful clip by Richard Feynman on YouTube, a lecture about computers. And he has this short bit where he says, one of the really horrible things or sad things in the world is that we tend to name things slightly wrong. And mayhem ensues. And one of the things we've named wrong is the computer, because computers don't compute. They're filing cabinets. We store data. We push data around. And so I always laugh nowadays when I see the new language X and it's multi-paradigm and it's procedural, object-oriented, and functional. And I'm going, wait a second, these are all the same thing. You're calling something and it returns. Get over yourselves. These are not paradigms, certainly not in the Kuhnian sense of being incommensurable, that you can't even talk about the differences. Like we know exactly what they are. And Guy Steele also identifies this quite a while ago, actually, that it's no longer about completion. It's not method and the method completes, but it's about ongoing relationships that we have to express in our programs, but we can't because we don't have them. And there was Oscar's invited talk a while ago about the death of object-oriented programming, and he explained that we were told we could just model the domain. That was what objects were supposed to do, and instead we're doing meta programming this and just building these edifices. We're not modeling domain with our programs, and again, it's because the domain doesn't have completion, and the tools we use have completion, and so they don't match. And Andrew Black, this is well known in the community, but he really put a finger on it, and he said, good students of object-oriented programming, he knows the student will be good when they start anthropomorphizing their objects. Right? They're no longer thinking about the program, but about the running objects. And that's sort of where this really comes to fore, because we have the static program text, and we have the dynamic execution. And if there is a difference, particularly if there's a large difference, we have a problem, because humans, and this goes back to Dijkstra, the Go to Considered Harmful actually talks about this very issue, is that humans are very good at looking at static relationships, they're very bad at tracing in their head dynamic unfolding executions over time. And when we had sort of this, the traditional computing idea, I use Fortran as the go-to for that. And the code and the system and the problem were actually fairly closely aligned. And then, sadly, we have all these problems that are non-computational, really, in nature. And so the problem is kind of, moves out of the way, and we have a hard time modeling these with that type of language. And with object-oriented programming, that was great, because now we can actually model the systems, create those systems that model those types of problems. And yay us. The problem is now we have that gap that Dijkstra was talking about. And I think everybody is aware of this gap, and a lot of effort has been poured into this gap. Certainly, the Smalltalk community is very much about, oh, the code is not important. It's the tooling, and we need better tools to examine the running system, and that is right. That is correct. And then you have the people who are saying, oh no, we need to abandon program text altogether. We need visual programming, and that may be true, but I think a large part of that, at least, is that the visual representation that they're thinking about are not close to the program text. They're close to that system, and so that's part of that desire for alternative representations of those programs. And then there's the modeling guys who say, program text should not exist. We just auto-generate it from the model description. Of course, that's just programming by another name. And then, there's Ruby, and then the gap becomes incommensurable. And then, of course, the FP guys said, this is all horrible, this gap. And that's actually also something you find in industry, I find, is that let's not have these horrible systems, because that gap is terrible, and architecture astronauts are everywhere, and they're not wrong, but they're also not completely right, because we still have these problems that don't really fit that model of call and return all that well. And so what Objective-Smalltalk is trying to do is, well, let's move that. Let's get the code representation closer to what those systems are. That's what I'm trying to do. And so what are the solution ideas? Well, Alan, on the Squeak mailing list quite a while ago, I said, guys, let's not argue about all these details. Right? The really big thing is you need to figure out the meta system, and then everything else pretty much falls into place. And I'd actually recently looked at Unicon, the Universal Connector Language from the CMU guys, and that was one of the first architecture description languages that was actually productive. It didn't just describe the system, but you'd actually hit a button and then it would generate the system for you. And it turned out that in that system, the connectors were actually essentially equivalent to the programming language metasystem. And it's like, oh, that's nice. That might be a good metasystem. And the other thing you learn from Smalltalk, of course, is that you want to decouple the implementation hierarchy from the conceptual hierarchy, right? We have, array is how collections are implemented, but it's somewhere in the tree, somewhere hidden, and the same with small integer. These are not the same, and all our metasystems tend to actually be very close to the implementation. It's like, this is how it's implemented, and you can, here's a couple of knobs you can switch around. And so the solution that I thought that we need a metasystem that's a conceptual class hierarchy of connectors. So that's, of course, very far away from what we have, and so then we need some kind of approach to get there. And the approach is essentially to implement different architectural styles without language support, because we don't know what the language is supposed to be like yet. Then add the language support, and then see how we can generalize that into a metasystem. And so some of the architectural styles that are very interesting, that exist and also are very successful. Of course, objects and messages, we're going to keep that one. Pipes and filters are really nice. They have very, very useful properties, and I had uses for them. Then there's implicit invocation for MVC and constraints. And then there's REST, and there's a story with that. So objects and messages in Objective-Smalltalk, we change that around from other Smalltalk systems that we have Objective-C compatible semantics, so it's not a, it's a capital T Smalltalk, but it's very close in many, many respects. It's interpreted and native compiled, and it does all the Objective-C stuff, except it doesn't it bases the language on Smalltalk, and so you get the C type of things by adding type information. And ideally, actually, I'd like that to be more, more D or Rustish, because, C is horrible. Then we add higher order messaging, which I've talked about and Steph has probably also, I wrote the paper with Steph on that a while ago. And you get into framework-oriented development where the functionality doesn't reside in the application, but you just compose frameworks together. And that's been working really well. And that, of course, you get full platform integration. And for example, this presentation is actually done as using a small framework based on the SceneKit, which is a 3D scene graph rendering library on Mac OS. Next architectural style supported is pipes and filters, and there's a paper on that in this October in Athens at the DLS. And essentially, the discovery really, it's not a huge discovery, but the conceit is that you can actually model most of what you want from a pipes and filter system completely with objects and messages by having a singular message, which I call write object, possibly a bad name. And then every object that supports every class or every object that supports write object can participate in this pipe and filter mechanism. And it receives an object by somebody sending it the write object message. And if it has something to write to its target, then it also says write object. And to that, we add triple dispatch and message chaining so that the filters can react dynamically to different object types. And what's interesting is that a discovery that I found interesting is that this is asynchrony agnostic. So actually, it's mostly synchronous, and that's nice because you don't have to have asynchronous processing. But if you add asynchronous processing to the mix, it doesn't really make a difference, except for the contribution that you want. For example, we used this in Microsoft To Do for the web, in interfacing with the backend. And since the connection is data flow oriented, again, the call and return part doesn't really matter that much. And the other thing, of course, you get performance because it's streaming. So that's one of the things in the DLS paper is that, for example, when you write serialized objects, you can be hundreds of times faster than if you try to actually construct that graph using call and return. And used for PDF PostScript processing, for example, in Squeak, there's actually the PostScript support. That's actually a simple version of that polymorphic write stream. Again, we used it in Wunderlist, Microsoft To Do. And another thing that's interesting is that you can actually map call and return on top of those streams, but it's more difficult to do it the other way around. So there's a question whether filters actually generalize methods. That's something to explore. Implicit invocation, just a really short, is that when you have interfaces / protocols, and then we can just actually say to create a subclass of this interface connector that is a notification protocol. And then when a class adopts that means tells the class, please listen to this notification. And everything else happens automatically. That was really surprising. Bigger one is in-process REST. And so the REST architectural style is somewhat successful. It's the basis for the largest computing system in the known universe, billions of computers, and it's what large-scale networks actually use, right? And the funky thing is, of course, objects and messages, in the way that Alan conceived of them, that was sort of the same kind of idea. He imagined what would networks of computers be doing they would be sending messages, and he said, well, let's scale that down. The problem was he didn't have an actual network to look at, right? He had to imagine the network because there were no large-scale computer networks at the time. And it turns out that, well, nowadays we do have large-scale computer networks, and they don't actually use objects and messages as at least at the conceptual level. I mean, implementation obviously underneath, and they use REST, and there's reasons that they do. And there's reasons Corba, the internet, the World Wide Web does not run on Corba. And to get in-process REST, we have a couple of components that I'm going to talk about: polymorphic identifiers, stores, storage combinators, and all this is used in a bunch of applications, so it's been tried out. So polymorphic identifiers, actually I should have referenced, there is a paper a couple of years ago, and it said essentially it just extends what we have in the programming language is that all identifiers are now URIs. So, they can have schemes, you can leave them out, then you get a default scheme. And you can, also, and all interactions with complex storage mechanisms can be done using those URIs. For example, so I think the first line var hello is pretty obvious. The second one maybe needs a little explanation. It says, take the Objective-Smalltalk homepage, HTTP objective.st, and store that into the download into the file site in the download subdirectory of the user's home directory. So we have some a string interpolation going on there, and then we can also get references to any object or any identified entity, and we can use that, for example, in user interface. So the value holder idea is kind of integrated into the whole thing by default. Polymorphic identifiers are evaluated via so-called stores, or you can also call them scheme handlers. And they're really just like in-process REST servers. Or the alternative way of viewing them would be it's a composable dictionary. It's very, very similar. So var hello essentially is the same as, well, go to your schemes, look up the var scheme, and there look up hello. That's really what that is. And of course you can use that without the language support. The language support just says, well, we're going to have every variable access look like that. And it's really simple, but very powerful. And so, what are example stores? Well, of course, we saw a couple: local variables, instance variables, environment variables, any kind of file system, HTTP databases, have a SQLite scheme. For example, other applications via Apple events, and so on and so on. Anything where you can store data that is potentially hierarchical, you can just put in there. And and you can use it just like anything that's built in. So, and that's one of the interesting things is that, most of the programming languages have some kind of storage mechanism built in, and if you want anything else, you then need to have a procedural abstraction to talk to, which is different from the built-in stuff. And that also means that whereas some programming languages obviously have built-in persistence, it tends to be tightly coupled. With this, you have modular built-in persistence. Storage. The other thing, when you have such a small protocol, which is again REST or dictionaries, that means you can start combining these, right? Instead of just having something that stores stuff, you can have something that looks like it's storing stuff, but it's actually delegating this to somewhere else. And that means you can have generic intermediaries, and again, you can have these components that you can just plug together, a lot like Unix pipes and filters. And once we use that in production, we got huge productivity boosts because, again, it's not quite clear why, but certainly part is of the composability. You just plug something in and nothing else changes except the functionality is now there. And the other reason is that you don't have this mismatch going on, right? Because usually, well, very often what you present to the user is something storagey, and underneath you have storage, and then you don't have to actually map this to some other abstraction in the middle. And so here are some fairly simple compositions. This is very common. Most of the apps had something like that, which is you have your in-memory storage, which is some kind of dictionary, and you have your disk storage, which is, you have something that translates between JSON, for example, and the in-memory, and then that talks to the disk, and then you have a cache that, we'll look at the memory first, and if it's not there, we'll look at the disk, and if it's writing, we'll write them to both sides. That's a super common element, and the fact that this is now a graphical representation. The graphical representation is actually generated from the live objects because it's a one-to-one representation of what's there. And so this is slightly more complicated, but still just plugged together out of existing components. This is an asynchronous writer because the previous example had the problem that when it writes, it still has it'll block until the disk part has been written. This just sends those requests into a queue, and will write those out sequentially as fast as it can. I'm not going to go into detail. And then this I'm definitely not going to go into detail, but that's actually the storage hierarchy of Microsoft to do at least when I left. Of course, when I left the company, they immediately tore it all out because horrible. And again, the clue was we could just plug these things in and out and have new functionality appear, and at the very top, nothing would change except for the functionality. And so those were now some of the things that were implemented, but actually none of this was done with language support. This was all done in Java, Smalltalk, Objective-C. And so, but coming from that, we see now some potential need for language support. And so things that Objective-Smalltalk supports is we have class, method, and protocol syntax. So we can have source code in files if you want to, or in a workspace. We obviously polymorphic identifiers need support. There's a composition operator that just says, well, plug these two things together. There's a permanent assignment, which is it's like an assignment, but just says, please keep these in sync. So it does a data flow constraint. And then stores and filters are implemented as class templates. And stores also, because they need to deal with polymorphic identifiers, doing that using a method interface is becomes inconvenient. So I created this thing called property paths, and I have a quick video. Actually, this is a version of the video I did for the Innovation Awards. Let's see. Crap. What? Okay, that's. Yes, you can. Oh, okay. So let's just play that. And okay. So what you see here is that this is just to make everybody feel comfortable. This is a kind of a Smalltalk workspace, and yeah, you can print it, and the support for higher order messaging. Then object literals. The second one is an object literal, so you can actually name the class of the object you want to construct, and it'll construct something of that, an instance of that class. And we can do the usual, large integers. And yeah, it actually does work. So we can also do the whole thing from a shell. And shell scripts have sort of method headers that simplify parsing of the commands because you don't actually have to do it. The system does it for you. And then demo of polymorphic identifiers. So file dot is directory listing, and then we look at a particular file, we assign something to a file, and then we look at it, and yeah, the content is there, and then that's the home directory from the environment variable, and now we take a listing of the home directory, and then we make it fancy, so because we want to see stuff. Obviously, also works with HTTP, and I can type or edit video. And that's the HTML of the site. And then we can also expose things via HTTP because these in-process REST servers obviously are very easy to just expose. There's the error operator there. So the server is connected to the scheme. The scheme is an in-memory scheme. Now this is hooked up to a file, a directory, and there's actually now a storage combinated, the cache, and so we are composing 3 elements together. This is the app that I use to generate the Objective-Smalltalk site. So it has a method browser here, preview on the other side, and that's actually code that's being run every time. So it's kind of a combination of a, what are they called again? The, escapes me now. But, and the same so this is all run inside one process, but I can take this out, and then on a Linux droplet DigitalOcean, I think, it runs the same code, just in a completely different environment. And that's the architecture, so it's all introspective. So this is how these 2 pieces are put together. And this is embedded into my PDF PostScript viewer, so you can interact with that. And you can get the author out of the PDF. You can, move the pages around. You can close the document. La 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 la. This is an implementation of a scheme handler. So think of it as a class definition, which it essentially is, just a special kind of class. And so there's some method definitions, kind of a mix of Objective-C and of Smalltalk syntax, which, Objective-Smalltalk, you might think. This is the first property path. It's the root. So that returns all the class names. And then if you give it a class name and whether you want instance or class variables, that'll give you a list of all the methods and give you references for those. And just pause just briefly. The pipes are kind of like the semicolon, except you take the previous result and pipe it through. And that's actually proven very convenient because it avoids the brackets that you need to go back then if you have nesting or chaining of keyword messages. And it also goes to the whole thing of integrating with data flow, because essentially you can view the whole thing as things piping through lists of expressions. And that's now with the, if you have the actual method name, you can get the method body, or you can also put a method body there. And that then adapts to the Miller column browser to the actual storage that's underneath. But you can take this exact same Miller column browser and just hook it up to a different store, and then it's a file browser. And all the adaptation work is essentially making things into stores. And once you've done that, everything else fits together. You can HTTP it, you can UI it, you can access it programmatically. And that's sort of the end. That's the that's actually the presentation as complex object literal. There we go. And so that informs the meta system. Just very briefly, essentially, we're changing from apply eval to connect and run. And so apply eval is again, is a sub-concept. And then class becomes a subclass of component. Message interface are subclasses of connector. Components have ports, and connectors have roles, and we can then try to match these when we hook things together. Outlook, as I said, most of the implementation is doesn't really have anything to do with the language in specific, except it supports it, and all these things are useful. So we could port all of that to all the other Smalltalks. Certainly the stores and the polymorphic write streams. Polymorphic identifiers need syntax support, so that's a bigger issue. And then documentation, sample code, and there is a native compiler. It's not fully functioning. And tooling. And of course, I would love help with all this because it's a lot, and I think it's now at a point where it's useful. And so I could help with implementation, but I certainly also with people who have use cases. So any questions?